I'm sitting here with Stephanie, and she is the one who creates all the graphics for these videos. Together, we also make games for Windows and KaiOS. Although the games are made with C# and JavaScript, we always use Python to automate our work. Do you remember when we needed some of your images for KaiOS and we wanted to create an 8-bit pixelated look and feel?
I remember it was always a hassle to experiment with the settings and check the result in an image viewer.
That's right. We had these images that you drew on paper back then, and we wanted to get these pixelated versions. We take 1 pixel and smear it out over 8 pixels. So we took the left top pixel, which is a 1, and then smeared it out over an 8 by 8 area of pixels.
In the beginning, it wasn't easy to test it because every time you changed code, you have to open the image viewer again to see the result and go back to change the code, and that took always a lot of time.
I wondered how this would look in a Jupyter Notebook. Would you like to try together and convert an image and see how it works in a Jupyter Notebook?
I want to see that this is easier.
Okay, let's try it.
Sure.
I will install Jupyter Notebook on a local machine because that will be easier to get the images in them. So I create a virtual environment. And activate it. And I install Jupyter Notebook. I start Jupyter Notebook. And there we go. So the first thing I do is I create a folder for the images. And in my file manager, I copy 4 images to the project.
Can you use all image types, or do they have to be PNGs?
We are going to use a library called Pillow, and we have to use the supported images. This includes PNG, and if you want to know what else is supported, you would just have to read the documentation. But we have PNGs here, and I'm pretty sure that will work. So I create a notebook. And I'll call it Pixels. And what we can do now is we can just describe the steps that we need to undertake to open and change the images. After we've done that, we loop through the images, we open them, we change the pixels, and we show them on the screen. So loop, open, make, pixelate, and show the images. As I already said, we are going to use a library called Pillow to manipulate the image. So I already know that I need to pip install the library. So, and I think those are the steps that we need to take. So let's start by creating a list of the images we are going to manipulate. For this, we need to import OS. And I will create a list of images from the images directory. So let me show you what is in this folder. And that works. So to read these images, I need to add the folder name to it. So I will create a new list with all the image paths that adds the folder name to it. I will use some list comprehension for this. So let's see what's in here. Yep, that works.
Why don't you put everything in one field?
In one cell, you mean? Why don't I put this here? Each cell in a notebook allows you to evaluate and print the contents of something, but it is always the last thing in the cell. So if I would have put this here, then this images would not be shown to us anymore. So I still could do it, but I would have to print it instead of just typing the name here. And that's the reason why I put it in 2 cells. And this is also one of the reasons where I really like Jupyter Notebook, because it encourages you to put everything in its own cell and then just execute a cell, and you can see all the in-between steps. Because what you and I hate is when we look at a tutorial and somebody says, oh, this is really easy, and I'm going to type these 150 lines of code and type, and then at the end they press execute, and then you see the end result, but you're really lost after line 3 in the beginning of the tutorial. And that is one thing that Jupyter helps you really with, to show all these in-between steps. Now we have a list of images, and including the path where to get them. So now we can loop through them and open and pixelate them. So I create a new cell. And the first thing I need to do is, since I know that I'm going to use the Pillow library for this, we need to import from it. I import from Pill, and for this, of course, I need to install it. So I'm going to do that at the top of the Jupyter Notebook. And for this, I execute a shell command with the exclamation mark. And the name of the library is Pillow. So I will execute this. And that works. And let me just run everything from the top. Let's see if that works. It doesn't. Cannot import name image from Pill. I misspelled image. It's with a capital I. So let's execute this cell again.
Perfect.
The first thing I want to do is we need to pixelate an image. So let's say that we want each original pixel to be smeared out over 8 pixels. And I define this in the pixel width. Then we need the size of an image. Now we can extract this information from the images we are reading, but for this tutorial it's much easier to just define the size, because I know that all the images I copied are squares of 512 by 512 pixels. Having done that, we can start looping. So I will do for I in image paths, and let's see what this actually is. And those are the paths that we see here. So if I know that this works, I can now load the image. So I will create a variable called source image, and I use image.open, and I pass I, and watch what happens when I print this now. And I execute the cell.
So with this print code, you can show every picture.
Yeah.
And if you don't write print, you just get the last one.
Yeah, but I don't think it works in a loop. Let me check that. Yeah, then it doesn't print anything. But there is something interesting with what you ask, because if I put this at the beginning of the line and I execute, then I do get the image. So Jupyter Notebook is smart enough to understand that this is an image, and it will just print it for me.
Convenient.
Yep, it is. I think we drew this image for the search picture game back then.
Yes.
Okay, so the first thing we need to do is we need to get pixels from this original image. So for this, I create another variable. And I take the source image and I load it. So now if I would print this, you would see that instead of an image, we get access to each individual pixels here. We're going to take the source image and convert it to a target image. So I will create a result image. And this time I just say I want a new one, and the mode equals RGBA, and the size equals the source image dot size. So this creates a new image, and it would be empty. And what I do now is I also want the pixels from this. So now I have a source image and I have a result image that is still empty. Let's execute this and see if it works. It does. So look at this picture again. So this here is the original image where each pixel has a color. Yeah, they probably have values from 0 to 255, but here I just add some numbers in it. And what we're going to do is we're going to take this left top color and we're going to smear it out over this area. And we do then the same for this 6 here. We're going to smear it out over this area. To do this, we're going to use a very easy trick. We're going to use some floor division and then multiply it again by the pixel width. And I'll show you how that works.
So easy.
It's so easy.
If it works, then it's easy.
I need to loop through the target pixels because the target pixels are the ones I'm going to set with a new color. I use a loop, and for this I'm going to start with the lines, which is the Y value. So, and I'm going to take the size here, which is 512. And in this loop, I'm going to create a new loop. And again, I'm going to take the size. I take the result pixels and I access one of the pixels. I could put it to any color here, but what I'm going to do is I'm going to take the source pixels and just let me show you what happens when I just do this. And at the end, I will draw the result image. Now let me show you what happens now. I execute the cell and I just got a copy of the image, which is already very nice. So we know that the copying of pixels works, and we know that we can actually print the result image. So how are we going to make sure we are going to take only the pixel of the left top corner of each area? Well, this is actually, with a little bit of math, very easy, because I'm going to divide by the pixel width, but I'm using a floor division where it rounds it off to the bottom, and then I'm going to multiply it again by that pixel width. So for every range between 0 and 8, I will only get one value.
You get ints.
I get ints from this, yes. If I don't get ints, I will get an error because I cannot access an index with a float value. So let me do this also for the Y value. So I'm going to use floor division and then again multiply it by the same. And I think this should already do the trick. If I execute it, yep, there it is.
Very nice.
A pixelated squid.
And very fast.
Very fast, yeah. So the only thing we need to do now is we see that we only have one image, which is the last thing I evaluate in the cell. But I could actually, for each image, well, let's see what happens when I print the image. I can do a source. I can print source image here, and what happens when I execute it? I see there are 4 pillow images. But of course, that's not what I want. And Jupyter Notebook has a very nice function for this. It has the function, it's built in, called display. And if I execute this again, I need to spell it right, of course. It's called display. So I'm going to execute the cell again, and there we are. But these are not the pixelated versions, so I made another mistake. Yes, of course, I need to take the target image. So I execute it again, and there we are.
Yes, and can we adjust the pixels?
Yeah, of course. So we can make it more coarse or more fine. So I can say each pixel should only be 4 pixels wide. And then we see that it's a little bit more finer.
Yeah.
Or if I want to make it more coarse, I can say, let's make it 16 wide. And then we get this
nice.
result.
That's fast. That's practical.
Yeah, because this is something we could not do when we first did this. We always had to open the image then and see how it looks. And this is, of course, much easier to get it all in this loop of changing code and immediately seeing the result.
And now we know how to do this.
Thank you for drawing all these wonderful images for me.
Thank you for using those images again and again and again.
Well, see you next time.
Bye.